This is our project LabVIEW based automatic waste segregator. Proximity inductive sensor. It is used to sense metals. When a piece of metal enters the zone of electromagnetic field produced by the sensor, some energy may be transferred, occur, and this is known as eddy current. This helps in sensing. And the second one is proximity capacitive sensor. It produces an electrostatic field instead of electromagnetic field. It can sense metals as well as non-metals. Its sensing depends on the dielectric constant. And the third one is pneumatic cylinder. It is also known as air cylinder, which uses the power of compressed gas to produce a force in reciprocating linear motion. Controller. NIY-113. It is a controller that acts as an interface between LabVIEW and hardware. NIY-113 contains analog input, analog output, digital input and digital output. It can be connected over USB or Wi-Fi. The processor used here is Xilinx Z7010. Speed 6667 MHz. Memory non-volatile 256 MB. Accelerometer range plus or minus 8G. Power output plus 5 volt, plus 15 volt, plus 3.3 volt and minus 15 volt. The required power supply is of the range 6 to 16 volt DC. Here comes the connections of our project. We have used a NIY-113, a relay, a H-bridge and a DC battery. Here comes the pneumatic controller, which will control the pneumatic arm. This is the inductive sensor which will detect the metals. And this pneumatic arm pushes the metals into a bin. We have used a 300 RPM motor which will rotate such that all the objects come one by one. Here is the capacitive sensor which will detect the organic materials, and this arm pushes the organic materials into a bin. Apart from the organic and metallic substances, the inorganic material will be collected at the last. Now the conveyor is on. The paper starts moving on the conveyor belt. Once when the paper is detected, the capacitive sensor 2 is on. It is indicated in the front panel. Now the conveyor is off and the organic arm works. And when the organic arm pushes, the conveyor again is on. It is in on position until an object is detected. Once when the metal is detected, the metallic sensor 4 is on. Its indication is shown in the LED. The conveyor stops and the metallic arm works. The conveyor again runs. Now the metal is kept at the sensor 5 and the sensor 5 is now detecting. Therefore, the relay works and it gives an input to the MIRIO such that the pneumatic arm works. Now we are going to see the working demo of the project. Now a metal is dropped into a conveyor belt. The metallic sensor, once detected, the metallic arm pushes it into a metal collector bin. Again, a metal plate is dropped into the conveyor belt. Again, the same process is repeated. Now, the testing is done with an organic material. Once the organic material is detected, The organic arm pushes it into a bin. There is a box containing an organic material. It pushes it into an organic bin. Since the pen is not an organic material, it gets collected in an inorganic material collector. Now the testing is done with a plastic key and a leather purse. Since the leather is an organic material, it gets collected in the organic material collector and the key goes into the inorganic. We have planned to make two important improvisations for the implementation of the project in the future. 1. Avoiding landfills and incineration. When this project is implemented, the maximum amount of waste are segregated. All the three forms of waste can be sent for recycling and reuse. Example, metals can be recycled or reshaped according to its value. Organic waste can be converted as manure. Inorganic waste can either be disposed or recycled in proper way. Second one is intimation to concerned authority. When the collector is full, some intimation can be given to the concerned authority such that they can come and collect those waste for recycling and reuse. We would like to express our sincere thanks to the faculty members, our mentor, and the head of the department for their kind support and encouragement. Thank you.